grenade is a dangerous weapon that can be thrown at the enemy at any moment without prior planning. They are not designed to damage buildings and infrastructure. Rather, they are used to dislodge and disperse enemy forces from bases. It is highly lethal when detonated in confined spaces. Grenades are usually thrown by hand, called hand grenades. Hand grenades are again of several types, such as fragmentation grenade, high explosive grenade, chemical grenade, and smoke grenade. Each is used for different purposes. However, the basic mechanism of all grenades is the same. Currently, all modern armies use fragmentation grenades. It is very dangerous. A modern hand grenade generally consists of an explosive charge, a detonator mechanism, an internal striker to trigger the detonator, an arming safety secured by a transport safety. Today, we will know through this video how fragmentation hand grenades work, what is the basic physics behind it. All issues have been discussed, so let's jump to the main video. A hand grenade consists of several important parts: main body, safety lever, safety pin, striker, primer, delay fuse mechanism, and explosive material. The body of the fragmentation grenade is designed in such a way that under excessive pressure the entire body shatters and spills in all directions. It is these fragments that become extremely lethal. Its body is usually made of very strong materials such as cast iron, steel, fiberglass, etc. Let's discuss each topic in more detail. Under the safety pin is the striker. The safety pin holds the striker against spring pressure. Now, if the safety pin is pulled out, the striker will blow the safety lever and strike the primer hard. So a soldier holds the grenade in such a way that the safety lever does not trip. Now let's open the safety pin with the opposite hand. This results in the striker being freed from the safety pin but stuck in the safety lever. That means the striker cannot hit the primer as long as the grenade is in hand, resulting in the grenade not detonating. As soon as the hand is released, the striker will strike the primer by the spring pressure. The impact generates heat and creates sparks. As there is high explosive gunpowder inside the primer, so gunpowder catches fire. Now the question is how fire is produced by striking the primer by the striker. You can do this experiment at home. For that, first, you have to collect the nipple from the bicycle wheel. There are holes on both sides of the nipple. Add a support to one side and bend it to make it easier to hold. Now collect the gunpowder from the matchstick and fill the opposite side of the nipple with gunpowder. Close the hole with a nail. Now if we hit it on anything, it will produce a loud sound and fire. What basically happened here? Let's go deeper. As the mouth of the nipple is closed by the nail, air circulation is stopped. When it hits something, the nail goes in, causing the air inside the nipple to compress, which means the air pressure increases. We know that high pressure produces heat. The heat generated ignites the gunpowder and releases a lot of gas. When this high pressure gas comes out, we hear the sound. To better understand, rub a matchstick on the matchbox. This causes the gunpowder to catch fire. This is because friction produces mild heat, at which heat the gunpowder ignites, since gunpowder is a highly explosive substance. Here also the same work is done. The fire generated in the primary is transferred to the delay fuse. The delay fuse burns for about 4 to 5 seconds. Then that fire reaches the detonator. Detonators also contain gunpowder. This results in a small explosion, and the entire explosive inside the grenade ignites. TNT is mostly used as an explosive. TNT is a very sensitive compound. It is capable of producing an explosion hundreds of times more powerful than gunpowder. So let's see how powerful TNT actually is. First, there are 2 containers made of paper. Let's put gunpowder in one and TNT in the other. First, let's fire the gunpowder. You can see that the gunpowder burned very quickly, but there was no explosion. Now let's fire the TNT. You can see that TNT burns very quickly and explodes as soon as it is set on fire. This is because TNT produces a lot of gas during rapid burning, which means the pressure increases. Due to the buildup of such enormous pressure in such a short period of time, an explosion occurs when the gas expands. In contrast to detonate through gunpowder, a closed container is required. TNT, on the other hand, is so explosive that it can detonate without a closed container. However, when the TNT inside the grenade catches fire, the temperature rises to about 5,000 degrees Celsius within seconds, and a lot of gas is produced. The pressure of the produced gas increases so much that the body of the grenade bursts and scatters, and a huge explosion occurs. The explosion emits a loud sound of 170 to 180 decibels and emits a flash equivalent to more than 1 million candles within 5 feet, which can make a person instantly blind and deaf. About 50 meters from the blast point is designated as the danger area, within which any animal, including humans, will die horribly. Now the question is, how does TNT generate so much pressure after it catches fire, which is capable of shattering such a strong body made of steel? For that we need to understand some basic physics. As we know, any substance expands when heated. For example, when water is heated, it starts to boil, and when heated more, it turns into steam. Water is formed by combining 2 atoms of hydrogen and 1 atom of oxygen. When water is heated, the hydrogen and oxygen molecules vibrates, and their bond gradually weakens. As a result, one moves away from the other. By absorbing enough heat, the oxygen and hydrogen atoms separate and become so light that they evaporate. If we turn 1 liter of water completely into steam, do you know how much space would be required to keep this steam at normal pressure? 10 liters of space, or 100 liters. No, to keep the steam generated from 1 liter of water at normal pressure, about 1,700 liters of space will be required. That means a container so large is needed to hold the steam generated from 1 liter of water. Now, if we make this container equal to 1 liter, then you can imagine how much pressure will be generated inside it. Similarly, when TNT catches fire, a lot of gas is produced. At extreme temperatures, gas particles become extremely light and expand incredibly. This creates so much pressure that eventually the grenade body bursts and shatters. Now, one question is why the delay fuse is used instead of firing TNT directly from primary. A delay fuse is used to allow the grenade to detonate after some time. Otherwise, the grenade will detonate before it reaches the enemy, thereby defeating the objective. Of course, the soldier must throw the grenade from behind a wall or any solid object. Otherwise, the thrower may also be injured. Hope you understand how grenades work. If you like the video, don't forget to subscribe and like the channel and turn on the bell icon